Okay, we're marching through examples of using Fourier transforms of one kind or another to solve partial differential equation boundary value problems. I have a total of 9 examples. We're on example 5 now, and this is all that's left of this course that I call Engineering Math B. So 4 more examples and we're done with the course. And I want to do this example because it kind of violates, I had rules that I discovered, I guess, how to know which variable to take the transform with respect to and which type of transform. This is in 2 variables, x and t. They both show up as second derivatives. That doesn't narrow down. Range of x is semi-infinite, range of t is semi-infinite. So that doesn't narrow it down. So we can't tell really ahead of time which variable to take it with respect to. To complicate it, I look for initial conditions. Here's where x is 0, and it's a nice 0 condition. Here's where t is 0, and it's a nice 0 condition. So it's not obvious what variable to take the transform with respect to. When it gets that bad, I told my students I would give them a hint. So here I'm saying take it with respect to x. Another hint I gave them so they wouldn't have to spend too much time evaluating an integral was to tell them what that was. So if we take it with respect to x, semi-infinite, we know we're talking sine or cosine transform, and we look at conditions where x is 0. And there it's just on the function itself, so we use the sine transform. We have the a squared times the sine transform of this guy. Look that up in the sheet or where we had written it down before, is this. In this case, part is just 0, so that makes it easy. And on the right side, since we took it with respect to x, just the derivative of big U with respect to the second derivative. Collapse this down to its simpler form, and it is a standard ordinary differential equation we have the solution for. There it is. So now we have to find big A and big B. Here's where we stood, and here's the remaining boundary conditions. I like 0 conditions. They're usually easier to figure out. So let's look at this guy first. We can take the derivative Fourier transform of this guy. Is this guy evaluate the derivative of this guy with respect to t? It's big U with respect to t. So let's see, when t equals 0, the derivative, this guy's going to be assigned, so he'll be 0. This guy will be a alpha. And then he'll have a cosine, so it will be 1. E a alpha equals Fourier transform of this guy, which is 0, tells us that B. So that of all this, this is all we're left with. So that's what our big U is at this point. So now we just have this one last condition to do. Plug in t for 0 again here, and we just have A equals the sine transform. I gave it to you in the hint. Otherwise, I would have done the last trick. Use other methods to solve this, evaluate this integral. So now I have what big A and big B are. Plug it in. And there's my big U. Now all I need to do is take the inverse sine. Let's plug this into the formula. Let's see, I can pull non-alpha things out. Really just another thing. So here is my final simplified answer. What would have happened if I try to take it with respect to t? Let's try it with respect to t. So it shows up as a second derivative, semi-infinite, so we know we're going to use the sine or cosine transform. Let's look for where t equals 0. Here. This is a 0 condition. I'll use this guy, and it shows up as a derivative, so I'll use the cosine transform. Here I have a squared. This part is just the second derivative of big U with respect to x. On the right side, I have the cosine transform of U with respect to t. There it is from the formula. In this case, that's a 0. It leads to this ordinary differential equation, which is a good old standard form. Here's what we get for big U. Okay, so far. What else can we just use? That guy. Let's look at this condition. Look at with respect to t. So the transform of this guy would be just plug in x equals 0 here, and we just get a equals cosine transform of 0, which is 0. So we have a equals 0. So we're just left with this. This looks to be the solution, and we've done everything except this condition. Then when we try to do that, we just kind of get stumped. Cosine transform of this guy. We can't plug in t for 0. There is no t in this thing. We're just kind of stumped here. Maybe there's another way to go through this, but I'm not sure you can get through it. But we could go through it when we took it with respect to x. We didn't run into any roadblocks. Sometimes it might take some trial and error. That's kind of why I threw this example in there. All right, now we just got 6, 7, 8, and 9. Oh, I guess we had 5 examples. Now we only got 4 more. And we're done with the course.